For our network, we're going to create a simple one-layer network with a ReLU activation. The ReLU function is equal to max, 0, or whatever value we place through it. What that means in the context of a neural network is that we have some layer with weights W and biases B, and the output of that layer is going to be equal to the max of 0 and then W times the input X plus our bias. To define this in TensorFlow, we're going to have to define two variables, one for our weight, which we'll just simply call weights, and this is going to have a shape of 784 by 10, and we're going to initialize it using the Gloro uniform initializer, which is kind of mysterious at this point, but it's the recommended way to initialize ReLU weights. And if you want more information about that, there is an excellent book called Deep Learning by Goodfellow et al. Now that we have the weights, we're also going to add our bias. We're going to do the same thing, but this time we're going to call it bias. It's going to have a shape that's equal to 10, and we're going to initialize our bias to the constant value 0.1. Just to give you an understanding of the context of the shapes, what's happening is that our x variable is going to have some number of instances, which each are represented as a 784-dimensional vector. What that means is that when we multiply x times w, the result is going to be a 10-dimensional vector, which we're then going to add our bias to that to get a 10-dimensional output. The way that we will actually do that is using two functions. First of all, the tn.matmul xw function, which performs matrix multiplication on x and w, multiplying them together, and then by simply adding them. TensorFlow is smart enough to realize that if you're adding two vectors, you don't need to call a function to do that. As a result, our output here will be the y vector, and that will be the prediction that TensorFlow learned. So y is going to be the output of our simple neural network.